Laplace transform, which is very useful in solving differential equation and integral equation. So this is the definition of Laplace transform in here, and it's a linear operator. What it means is if it's constant can take outside, and plus can be equal to this as a linear property. Simple transformation, there are two examples here. And Laplace, this is just something related. Laplace equation, Laplace transform, Laplace operator here. Okay, here are more examples of Laplace transform in here. So let's see example 1. The Swift theorem is listed here. If it is P plus A, it will be Laplace transform of E minus AX fx. These are simple table of the Laplace transform. And inverse transform, what it means is if you inverse transform, you go back to the original function. And inverse transform can be obtained from table, or it can be obtained from complex variable come-to integration. I will show you later. So these are example. These are more example. So inverse transform can be obtained using the complex variable theory, especially come-to integral. I will show you later. Now let's see transform of differential coefficient. One first derivative and second derivative, you can do the Laplace transform, and this is useful to solve the differential equation. Okay. These are definition of Laplace transform and the inverse Laplace transform, and you can get it directly from complex variable theory, like this expression. So let's see the come-to integral. So you have a boundary like this, and you do the integration. This come-to integral in the complex. This give you some overview of the complex come-to integral. Something like this. Something like this. The real value and the complex variable. And you can see the come-to integral, and these are some examples. And from this you get the green theory or this theory. And to solve the differential equation using the come-to integral, just give you two examples. The second example. Now solution to the ordinary differential equation. And this is the way you get the solve the ordinary differential equation. These are example 1. These are example 2. And more example here. Example 3. Solve the differential equation. And the convolution theorem. So state the Laplace transform of f if function satisfy this, then you can actually equal to Laplace transform of the individual function. This is a convolution theory, and is useful to solve integral equation. So convolution of the Laplace transform, and you can see it's here, and these are again Laplace, something related to Laplace, something related to Laplace operator, and something gradient curve. Just give you some example of Laplace transform function. This is a function, this is Laplace transform. And we will go through all this. Tangent become this, cotangent become this, cosine Laplace transform to this. And when do the inverse transform, you just go from here to here. More example. Laplace transform again from book, and this more example here. This is so you can see the Laplace transform example. These are from book Laplace transform. Just give you some description, application in physics. And this Laplace transform of derivative of integral, convolution, and more example from the book.